the property here, let's let that load up. And do you have a list of properties, or is
Yeah, I have some in my notes.
okay. Because I don't want to give you like the wrong name that maybe your instructors is using, but this one it's like if A equals B, then B equals A. It's sort of like if you can go forwards, you can go backwards. And I'm leaning towards like a reflexive property. Is that something that you guys are using in class?
Yeah.
Okay, now just I gotta be careful here because there's two that come to mind, and this one I believe is actually the symmetric property. Okay, reflexive is something different. Reflexive is if it equals itself. Symmetric is when if A equals B, then B equals A, and that's what we're seeing. We're seeing here. Is that okay? Is that clear?
Yeah.
All right. These are sort of all over the place, so we'll just see how we do on them. If x plus 3 equals 17, then x equals 14. My question to you is how do you get 14 from this on the left here? What would you do? How would you solve for x on the left?
Subtract the 3.
Yes, so that's the subtraction property. All right, number 3. Think of 3 as the property where something equals itself. A equals A is how they usually show it. Something equals itself. This is the reflexive property.
Okay.
And that's where you can sort of say, okay, it's reflection. It's there. I found a pretty good website for, it's got so many here, but it's got the first few that we really care about. I'll spare you that for now. Let's spare you from having to look at all that, but okay, let's go to number 4. So I think the ones on the right where they're sort of algebraic in some ways where you know how to solve.
Mm-hmm.
In this case, what would you do to solve for x?
Divide.
Divide by 7. Yeah.
Mm-hmm.
So you can see that, okay, this is the division property of equality.
Okay.
Number 5 is very similar. It's an algebraic property without the numbers. If you look at the left, it's got an xy, a yz, and an xm. If you look at the right, it's got an xy, a yz, and an xm. Well, what did they do? They moved the yz over by adding it. They added yz to both sides, and that's how you sort of can work through this. Is ask yourself, what's the same, what's different? So this would be the addition property of equality. All right, number 6. So the question again is like, well, how do you go from the left to the right? You can see you multiply this 2 in, so you might think, well, it's the multiplication property, but because it's outside parentheses, that is the distributive property.
Oh, actually, I do have another thing. It's my IXLs for one of them.
Okay. Sounds good. Let's keep going here on this one. Number 7. number 7 here. So if M, measure of angle A plus measure of angle B equals 90, and measure of angle A equals 30, then 30 plus measure of angle B equals 90. So what I'm seeing here is they're taking this number and they're replacing it there. They're substituting it in. This looks like it's substitution. Looks like 8 is very similar. X equals Y plus 3 and Y plus 3 equals 10. Then X equals 10. It looks really similar, but to me, it's more like A equals B and B equals C. Therefore, A equals C. And that's the transitive property.
Okay.
All right, so number 2 is to complete the reasons in each proof. We've done a bunch of these past few lessons. This should be something that's very, very familiar to you. Let me just resize this a little bit. Okay, the stuff at the top is just the prove and the given and the prove. But I don't know why they repeat it here, but you always start with the given. Okay, you've got that down from previous problems. Now, what are they doing to go from A to B? What is going on where you're going from A to B? What do you see?
Multiplying, or they're distributing.
Yes. Even though it's multiplying, it's called the distributive property. All right, and then from B to C, you can see there's no more -6. What is being done here? How is it being manipulated?
They subtracted the 6.
They subtract the 6
they
or add the 6.
Added the 6.
So you can write addition property if you want. And then the last one here, they're dividing by 2. So that is the division property. How is that okay? Is that clear?
Yeah.
I mean, these are like the ones I think we did 2 weeks ago, or maybe 3. All right, let me know when you get all that down.
Okay.
All right, so the next one's really similar, just more steps here. Picture quality isn't very good on that, but we'll make it work. So the first one is always given. Given. And then the second one, it's like, well, what is it that they are doing to go from like line A to line B? What are they doing? And sometimes it's hard to see, like there's a 2 here, there's a 2 here.
They're multiplying it by 2.
Yeah, so multiplication property, or multiplication property of equality. Okay. And then from B to C, you almost want to like work it out yourself. Be like, well, what's going on? And if you multiply in, you get 6x minus 8. If you multiply it on the right, you get the x plus 12. But it's not multiplication property, it's something else.
The substitution.
Division.
Distribute. Sorry.
Yes, it kind of looks like substitution because you're substituting in some ways, but it's like you're multiplying and then simplifying there. All right. So how about now to go from C to D? C to D. What do you see that's the same or different on?
They took the X out. They subtracted the X
Yes.
by the 6X.
Yes, so you would say subtraction property. Yeah, so subtraction property, and then it's just a repeat. It's like, well, how do they go from D to E? What happened to that minus 8? Well, it was added to
Added
both. Yeah, so
to
we'd say addition property. And then from E to F, divide by 5, divide by 5. So division property.
Okay.
So you said you might have something else for us to look at for today.
Yeah, but I excel.
IXL, that's different than the delta math?
Yeah, you can log into my Clever.
I only have the delta math login
Oh, it's the same for all of them.
for
Pretty
all of
much.
them. Okay.
Yeah.
All right. Well, let me so can I go right to IXL for you and log in?
Yeah.
Okay. Let me new share that and see. So just to be clear, this is what you're referring to right here.
Yes.
Okay. Let me go find your login stuff. I do have access to that document from the other day. All right. Does not seem to like that.
Is it a thing where it says, well, because when I do it, I go through my Clever.
Okay, if you want to provide that, I'll be happy to, log in here. Otherwise,
The
we'd
Clever
have.
is the same thing.
I'm not familiar with Clever, so if you want to send over the link, you said Clever, and that's TUSD. But are you asking me to log in here?
Yeah. Log
Okay,
in with network credentials.
sure. Sometimes this will or will not work. Obviously they're me see it thinks
Sign
it
in
thinks
with
it,
other
it
account.
yeah it thinks there's. So let me use another account. There we go. All right, there it is. Now we're right here, IXL.
Mm-hmm.
I'm only asking because it's your stuff. I don't want to in any way. All right. Math.
Yeah, it's yeah, you go down to D7.
Construct an angle bisector like this. No, that's C. I'm sorry. Proofs involving parallel lines.
Yeah.
Okay. Okay. I mean, this is kind of like what we were doing last week. We'll see how well this goes. UXW. UXW. So this next angle here and TUX are supplementary. So that if these lines were parallel and they were cut by a transversal, then these would be supplementary. So the answer is it's the converse of corresponding angles. No, those aren't corresponding. Definition of supplementary angles. No. So that I'm trying to. So like I'm going backwards. I'm telling you that if the lines were parallel, then these would be the two angles would be add up to 180. UXW equals SUT. Okay, so they're saying that that angle there equals that angle there. That is the corresponding angles. They're corresponding because they're in the same relative position.
Mhm.
All right. Okay. Oh, wow. So you got to give all the steps here. All right. Angle SUV is congruent to TUX. So those are vertical angles. One's up here, one's here. That's vertical angles. Hopefully that's theirs right there. Do you have to submit it all at once, or can you check sort of one at a time?
Oh, you have to submit it all at once.
Okay. So UXY is congruent to SUV and UXY. Okay. TUX is congruent to UXY. So this one to me is like a trend. It's like a transitive property
Mhm.
of congruence. So it's like, since UXY is TUX, since TUX is SUV, that's why it works. And then they say the lines are parallel. That's always a converse of something. I guess in this case, corresponding angles. Like if they were parallel, you would get the bunch of stuff. If you're proving they're parallel, it's always converse. So we'll
Mhm.
submit that there. Okay. What's the goal here? Is there like, do you have to get a certain SMART score? Do you have to answer a certain number of
80 or
questions?
above.
80 or above? Okay.
Yeah.
All right. So RTU and XWY are supplementary. So the next one is the definition of supplementary angles.
Mhm.
If it's those two angles, and it is, okay. Now RTU and UTW, they are on a line. So that's going to be like definition of our angles forming a linear pair sum to 180. So like the first one comes from the given, the fact that they're supplementary. The second one is, hey, they're both on the line, so they sum to 180, right? And then they say, okay, RTU plus WXY must equal the other one, WXY. So they're saying that they're like they rewrite the two letters again, and then you can see they subtract out the RTU from both sides. So these two angles are congruent. Measure of
Mhm.
angle XWY is congruent to UTW, and those are corresponding angles again. So it's gonna be another converse of corresponding for that. All right, so that's given. That's given. SVU is congruent to QSR. SVU. Okay, so that's because they're parallel. You can say that corresponding angles are congruent. That's the corresponding angles theorem, I think. Let's see what else? Yeah, that looks right. Measure of angle QSR plus measure of angle RSV equals 180. They're on a line, so that's a definition of, or two angles, angles from a linear pair add up to 180. Again, QSR, RSV, and then they substitute in for one of the angles. They're saying, hey, don't use QSR anymore, use SVU. So that's going to be some sort of a substitution there like that. Wonder why that one only gave 7 points. Okay, this one is given. again, given VWY congruent to STW. Because they're parallel, those are corresponding angles.
Mhm.
Then RTS, STW. That's the angles from a linear pair, sum to 180. And then they're substituting again because the angles are congruent.
Mhm.
So it looks like that's substitution. All right. Complete the proof that angle VUW is congruent to angle PRQ. So we know that that's what goes in the last line there. VUW congruent PRQ, like that.
You forgot the A.
Yes, that is why I didn't take it. There it is. Okay. Doesn't look right. All right, now it does. And then why is that? If you just look back here, it looks like it's like, okay, A equals B, VUW equals SRU, SRU equals PRQ. So they, by the transitive property, A equals B, B equals C, so A equals C. By the transitive property of congruence, not equality. Equality is for something else.
Mhm. Oh,
It didn't. So I guess there was more. I don't get it.
reflexive property of congruent.
Okay, and it looks like it knocked it down. That's frustrating.
Yeah.
Okay. Hang on just a second here for me. All right, I'm back, Jasmine.
Mhm.
So let's take a look here. Transitive property of congruence. So we want to prove that TV is parallel to WY. And it looks like if we've got WXZ is congruent to TUX, those are corresponding. So it's a converse of corresponding angles. All right. So let's try that. Hopefully that's better. Okay, so it took that now. This looks like the one we were kind of just doing.
Mhm.
I mean, this looks exactly the same as the one we were just doing where it marked us wrong. I should have looked at that more carefully, but it's VUX congruent to UXW, angle UXW. And they called it reflexive property of congruence. I still don't know that I believe, but we'll just go with it. It's the transit property. That's what I thought it was. Okay. All right. Oh, goodness. Okay. So we know to go that last line and write TV parallel to WY like that. And then what is it? So if UXW is congruent to SUT, that's the converse of corresponding angles. Again. All right. So this one's the same thing. TV parallel to WY. Like that. And since UXW is congruent to SUT, that's converse of corresponding angles. These are proving the congruence. There it is. Okay. All right. So you said that's sufficient for that?
Yeah.
Okay. And hopefully it was clear what I was doing. I mean, just that you can read through all these, but sometimes when they're telling you the proof statement, you just go to the proof statement and see what it is.
Okay.
All right. What else? Anything else you want us to work on today?
No, that was all I had.
Okay. They'll so that's good. Do you have a test or quiz upcoming in this class? Maybe next week before spring break?
No, not that he's told us yet,
Okay,
but I think the only thing we have coming up is benchmark tests.
got it. Okay.
Mhm.
Well, we can stop right here, and I will see you next Wednesday. And I know we're skipping the following week, but we'll do whatever you need to do to get ready for that or something else.
Uh-huh.
But that is it. I'll go ahead and stop the recording.